To talk about reaction pathways, I'm going to choose a starting material such as ethene, an unsaturated that has a double bond. You can make number of organic matter from this, other families. So the first thing I can do is add hydrogen to it in presence of nickel catalyst, solid form. And then what you do is you saturate this alkene and you produce the alkane, which is ethane. Now, alkanes are unreactive, but remember they go through combustion as well as substitutions with halogens, so I can add chlorine. Of course, you need sunlight or UV. If you do that, you produce CH3, CH2Cl as one of the possible products, a chloroethane. I could have done another reaction to my alkene by simply adding a hydrochloric acid to it and give you the same haloalkane. Once you have a haloalkane, you have many possibilities. I can go through substitution. I can add, for example, potassium cyanide to it. And this is a substitution nucleophilic bimolecular. Chlorine is going to be substituted with cyanide. So I produce a nitrile, CH2C triple bond nitrogen. You can add hydrogen to this, hydrogenation, nickel catalyst one more time, and then you open it and you have an amine, CH3, CH2, CH2, NH2. So this is propane nitrile, and this is 1, 2, 3 propane amine. And the starting material, remember, was ethene. What else I can do is I can take my halogen and let it go through substitution, and I can add sodium hydroxide to it, dilute. And then again, this is another SN2, so so let this be a plus sign I'm adding, and then I will give you an alcohol, CH3CH2OH. Let me make this a little bit nicer. So I want to give you an alcohol, so what I'm going to do is add NaOH, sodium hydroxide, dilute. The solvent is water, and I will give you an alcohol. Once you have alcohol, and in this case, remember this is primary, I can add the oxidizing agent, potassium dichromate, sodium dichromate, in presence of sulfuric acid, and give you an aldehyde, CH3COH, ethanol. Now you still can add the same oxidizing agent or just do a reflux distillation, and this will turn into a carboxylic acid, ethanoic acid. Now a number of other reactions can happen. The alcohol can react with the carboxylic acid to give you a condensation reaction, and since you produce an ester known as esterification. So plus catalyst, sulfuric acid, and heat, I can make you an ester that the first name or first partner is my alcohol. You condense a molecule of H2O, and this is an ester linkage or ester functional group. So the first name of the alcohol is ethyl, and the last name is last name of the carboxylic group, which is ethanoate. What you can do is take also the amine up here and add it to the carboxylic acid. And what you will form is an amide. And let me just do that. I'm going to take this arrow, bring it down here so I have more room. And I can have the first name of amine, CH3, CH2, CH2. One of the nitrogens of amine goes away to form H2O, and then the OH of the carboxylic acid goes away. So you are left with C double bond O, CH3. This is the new linkage or functional group known as amide. So these are possibilities, and this is one possible reaction pathway starting with ethene. You should do something similar to this and see if you can bring the rest of functional groups to life.